The Japan Testing Center for Construction Materials is a third-party organization which has been in operation for more than 50 years in Japan, specializing in quality performance testing ministerial approvals, certification under JIS and JAS, and approval of building materials as specified under the provisions of the Building Standard Law. Currently, we have a hub network in various locations from Sendai in the north to Fukuoka in the south as the trusted third party of certification. Among them are Nishinihon Test Laboratory in Yamaguchi Prefecture and Fukuoka Test Laboratory, which have focused on servicing Western Japan. The business outline at Nishinihon Test Laboratory covers the quality control tests for construction materials and civil engineering, the tests accompanying the performance evaluation, the construction material tests related to concrete and steel used for building and civil engineering. The Fukuoka Test Laboratory covers only the construction material tests. Let us show you the characteristic advantages that satisfy our customers. Let us introduce some of the characteristic advantages our Nishinihon Test Laboratory can offer to customers. Our history started in 1974 in Yamaguchi Prefecture as a testing hub in Western Japan. We are a third-party testing organization representing Western Japan. We have a fire resistance testing facility, building structural testing facility, and durability test instrument that are the largest in Western Japan. The test site building over there was opened in 2013 in order to further fulfill structural and material tests. We have prepared the only capable testing facilities in this Western region. We can serve our customers with a full-range menu of satisfactory testing capabilities. Now, we would like to introduce our testing items as the test laboratory of an accredited body. Here you find the testing items offered by our Nishinihon Test Laboratory. In the area of material testing, we offer physical property tests, chemical analyses of civil engineering materials, and durability testing. For structural testing, we offer strength tests for various structures, the components and parts in civil engineering that include joints. Related to fire resistance testing, we can perform tests for beams, floors, and walls, as well as testing for fire preventive materials, equipped with the largest fire resistance testing facilities in Western Japan as the performance evaluation organization under the provisions of the Building Standards Law. Regarding quality control testing for construction materials, we offer testing of concrete and reinforcing bar, as well as quality control testing for building construction on site. Finally, in the area of construction materials testing, we have organized and are conducting the quality management system to comply with JIS Q17025 and ISO IEC 17025. Thus, we are registered as an accredited testing laboratory by JNLA, Japan National Laboratory, as well as MRA, Mutual Recognition Arrangements. The last sales point is our human resource education and management. Our belief is that highly trained engineering capability is indispensable for our technical staff in order to coincide with the reliability and processing speed of testing performance. We have long sought to improve the engineering capabilities of our staff by working with outside organizations such as universities. These are our 5 characteristic sales points for the Nishinihon Test Laboratory. Now, discussing briefly the characteristics of Fukuoka Test Laboratory. The testing menu we offer here is testing of concrete and steel, and construction materials tests for in situ quality control. Fukuoka Test Laboratory has been running the quality management system compliant with JIS Q17025 and ISO IEC 17025 and is proud of its credible engineering capabilities as a testing organization. The laboratory is also located for convenient access to Fukuoka International Airport, known as an entrance from East Asia. Let us introduce the material tests. First, the ozone resistance test targeted at organic materials. The main test material subjects are those made from rubber and gaskets. The ozone contained in the atmosphere is very little, but we control the ozone gas concentration in the test instrument, and we monitor the appearance of cracks to confirm whether the material meets durability targets. Next, we show the freezing and thawing test targeted to the inorganic materials. This test mainly targets the reinforced concrete. By repeatedly freezing and thawing the trapped water within the concrete, the expansion by freezing the water and corresponding internal stresses creates cracks and separation on the concrete surface. This test observes the surface of the specimens, calculates the relative dynamic modulus of elasticity, thus providing evaluation of quality against frost damage. This is the structural test. This shows the in-plane shear test of the wooden framework bearing wall. It aims to survey the degree of resistance of the bearing wall, the wooden framework structure, against the forces experienced during an earthquake or horizontal forces due to wind pressure. During the test, we measured the displacements and load force of the parts and visually confirm any damage to the sample. The large in-plane shear test equipment located in our Nishinihon test laboratory is particularly known for its capacity to test larger test structures than those of other test laboratories. This is the fire resistance test. The fire resistance test is utilized to confirm that a building structure will not collapse and the performance of flame interception. The fire resistance test of a beam involves heating similar to levels anticipated during a fire, while adding load to parts of the building structure and measuring the fire resistance performance parameters such as volumes and speed of deflection. Next, we introduce the drop impact test for the fire-resistive containers. This test is to confirm the protection ability of the safe for the contained assets during a fire. Firstly, the fire-resistive container is heated to 1090 degrees Celsius, then dropped from the height of 9.1 meters to simulate falling within a building. Thereafter, additional heat to monitor the fire resistance. Let us show you the testing of fire preventive materials. The fire preventive material test confirms the fire resistance ability of interior or exterior materials of building structures during a simulated fire. By exposing a specimen to the radiant heat, the pyrogenic test confirms the fire prevention performance of the interior and exterior materials by measuring the pyrogenic speed and degrees of the test body via monitoring crack penetration within the specimen. Let us show you the quality control testing for construction materials. The concrete compressive strength tests confirm whether the strength of the concrete placed into a structure conforms to the design rules. To test, gently place the testing body within the testing machine, then add compressive load until demolition, whilst monitoring the strength parameters. Let us introduce CBR test of sub-base to build, a category of construction materials. The CBR measures the loading capacity of sub-base by compacting the crushed rock materials utilized to pave roads and airstrips in order to increase safety, durability, and load-bearing capacity. Steel slags contain some residual sulfur, which can react with water, causing expansion and damage to subbase. This test measures the amount of expansion characteristics of the specimens by repeatedly heating and cooling the steel slag specimens in the water for 10 days. Fukuoka Test Laboratory operates various test equipment for construction materials, including a steel bend testing machine, a tensile testing machine, 2 universal testing machines, and 3 compressive testing machines. Here we demonstrate a compressive strength test of cement milk. Cement milk is a pile material to support a building, which is a very important part of building foundations. The cement milk is sampled at the on-site construction to fabricate specimens. After the specified curing time duration, the specimens must clear the required compression strength regulation. We offer further compressive strength test services for residential housing foundation concrete. Customers use the delivery services for sampled concrete by our sampling package, as per the instruction manual previously sent to the customer, or via the delivery services for sampled test specimens at a ready-mixed concrete plant and cured for test of age. Next, we demonstrate the steel tensile test. This testing machine performs tensile strength tests of materials and joints of larger diameters over 51 millimeters and reinforced bar of high-strength SD490 to confirm fracture positions and tensile strength of the test pieces. Tests for machine joints of larger diameters are performed by widening the piece up to the necessary length to allow grip adjustment of the testing machine. Our engineering advantages are certainly based on our experiences nurtured by technical know-how over 40 years. The day-to-day testing is to ensure the quality of buildings. We are proud of supporting the safety of buildings, our history of a number of tests done in a variety of fields of construction and construction materials. Ask us, what kind of performances do we need to confirm? We provide the necessary tests for your requirements. Nishinihon Test Laboratory staff aim to be the leader of testing in Western Japan. We await your contact in order to offer speedy and accurate testing services from initial inquiry to issue of the final test reports.